Well guys, let's work on the sixth problem, a very easy problem. Let's visualize the problem first. It says A, B, C, D are the vertices of a quadrilateral. So let's just write a quadrilateral somehow with a four-sided figure. Cool, we got this guy. So let's name these guys A, B, and C, and D. That's what you have. Now A is given as 0, 0. Okay. B is like 7, 2. All right. C is given as 7, 7. All right. And D is given as 2, 7. So that's what you have now. Now what can we do with this? He's asking you to find the slope of each diagonal. So which are the diagonals basically? AC is a diagonal and BD is a diagonal. This is what you have. So to find the slope of AC and BD is what you're looking for, right? Now let's find the slope of BD. Now let's say B is given as like 7, 2 and D is nothing but 2, 7. So I'm taking this as x1, y1. This guy is x2, y2. No problem. So what's the slope? Slope is like y2 minus y1 by x2 minus x1. That's it. So what's the formula? Who's y2 now? That is this guy. That is 7 minus 2 divided by 2 minus 7. So what you get, that is like 5 divided by minus 5, which is minus 1. So that is the slope of it. Nothing much. Cool. So I can write a slope of BD is -1. Well guys, the problem is nice and easy. We understood how to find the slope of AC and BD, but there's some extra information you guys should know. That if at all I have two lines which are parallel, I can say this guy's slope is M1, this guy's slope is M2. Then I say that M1 is equal to M2. Now this is a condition for two parallel lines. And let's suppose the angle between two lines is like 90 degrees and this guy's slope is M1, this guy's slope is like M2. And if I multiply them as M1 into M2, if it is -1, then I say that these two lines are perpendicular. And look at that. Here, if I see the slope of AC and BD, if I multiply them, right, slope of AC into slope of BD, what am I getting? You're getting 1 times -1 is like -1. So it means what? AC and BD are actually perpendicular. It cannot be like this. Then the quadrilateral is not a trapezium. For us, it has to be either a square or a rectangle. No, not even a rectangle. It has to be a square or a rhombus. Why is that? Because in the square and the rhombus, the diagonals intersect at 90 degrees, right? So it can also be a rhombus, not a problem. So that would be one of the diagonal, yeah. And the other one is like this. And if you draw this guy, that is 90 degrees. That's it, nothing much. So we can guess the kind of quadrilateral is by even knowing that the product of the slopes of the diagonals is like -1. The diagonals should intersect at 90 degrees. So it has to be either a square or it has to be a rhombus. That's how it is.